When sensitive data is used for research, it's important to remember that all the data processing is done inside a trusted research environment, or a TRE. TREs are digital systems where sensitive data can be analysed for research in the public interest. TREs are typically governed by the 5 SAFEs principles, which are safe data, safe projects, safe people, safe settings, and safe outputs. Importantly, before any data can be used for research, they're de-identified. This means any information that might identify an individual, like their name, their address, any numbers that could be associated with them, are removed from the dataset. This is what makes it safe data. To make sure the data stays safe, all research access to them is done inside a safe setting, the TRE. You can think of a TRE as a digital version of a chemistry fume cupboard, a big glass box with a pair of rubber gloves glued into the side and a rule book of lab do's and don'ts. With a fume cupboard, a researcher will put their hands inside the gloves and they will manipulate whatever dangerous chemicals have been put inside there by the lab technician, following the rule book. They can't take things out and they can't put anything else in. And if they come up with any neat result, any particular new substance, they have to call the lab technician to say, please, could you take this out for me? Digitally, that's what TREs are like. You can log into them if you've been approved as a safe person, and you can access the data that have been prepared for you. You can't download anything from the environment, you can't upload anything to it. You can't even copy and paste. You have no access to the internet at all. TREs are locked down, and for very good reason. What do researchers do inside a TRE? That depends entirely on what their research project has been approved to do. Researchers don't just get access to all our data and get to play with it. Before they're allowed to log into a TRE, they will have applied for access to specific data sets for a specific research topic that they have. Together, those data sets and that topic make what we call the SAFE project. And a project can only be approved by the relevant data governance authorities if it's deemed in the public interest. That's the legal basis on which research in TREs can happen. What the researcher does next depends on the research topic that they're investigating. They may be doing something as simple as plotting graphs using Excel. They may be writing data science programs using languages like R or Python, or they may be applying more complicated techniques like AI. The important thing to remember is they can only use software that's been placed in the environment for them. They can't put their own software in. Any software that they use will have to have been installed for them by the TRE operator. So when we say artificial intelligence or AI in terms of TREs, what we usually mean is machine learning. I think of machine learning as a fancy way of doing data analysis. In traditional data analysis, using statistical software, you might draw some points on a piece of paper and maybe you think, I can draw a straight line through these data points. The straight line you draw through the data points is called a line of best fit, or sometimes a linear regression. That line of best fit is a statistical model. It describes a pattern in the data. That's what models are about. And that statistical model gives you the ability to predict patterns in a new data set based on what you've learned from the old data set. So when you have billions of numbers in your data set, you can't draw the graph anymore. But what you can do is apply machine learning techniques to the data to look for the patterns for you. And a machine learning model will absorb the data and it will create a statistical model which describes the patterns it sees in the data. And that statistical model, if you apply it to new data that the model wasn't trained on, it gives you the power to predict the patterns in the new data set that you show it. Inside a TRE, machine learning can be used to look for patterns in, say, a very large collection of medical images. These are medical images, they have to be kept inside a TRE, but a machine learning algorithm can be trained to look for unusual features of, say, lung X-rays. And this gives a statistical model which can then be used to predict whether a new set of lung X-rays that the model is exposed to have any unusual features in them. This gives us a tool, potentially, that can predict the onset, say, of lung cancer. When a researcher working in the TRE thinks they may have trained a neat algorithm to find unusual features in lung X-rays, they can't just take that model out themselves. they have to contact the TRE operator and request that model be released as an output. That's where safe outputs come in. The things we have to think about are questions like, does the AI algorithm remember the data that it's been trained on? The short answer is yes, sometimes it does. It can depend on the precise nature of the algorithm, but yes, it does. But does it matter? Remember that even before the project started, all the data involved were de-identified. They were made as safe as possible, and the project has been assessed as safe as possible. So, does the AI model pose a risk to anyone's privacy? And what can we do to control that risk? DARE UK has funded a number of projects over the years to explore the issues around the use of AI inside trusted research environments and the release of AI models to the outside world. The SACRO ML project, which stands for Semi-Automated Checking of Research Outputs for Machine Learning, is building tools to support human output checkers on assessing the safety of releasing machine learning models from trusted research environments. Beyond these projects, DARE UK, along with researchers, technologists, and the public, is exploring innovative new ways to create secure, safe solutions to enable research in the public interest.